Resonance structures are the two or more Lewis structures that are equally correct for a species. For example, let's take the nitrate ion, and if we count up valence electrons on that, we'll get 24. With a little experimentation, we could get this for one of the Lewis structures for the nitrate ion. We notice that each atom has an octet. However, the distribution of electrons is not the same on all of the oxygen atoms. This oxygen atom on the left here has 3 unshared pairs and a single bond to the nitrogen, whereas the oxygen atom on the right has 2 unshared pairs and a double bond to the nitrogen. Is there any good reason why we drew the double bond on the right and the other 2 single bonds? Couldn't we just as well have drawn the double bond on the left, or the double bond down on the bottom between the nitrogen and the oxygen that I've shown below? And the answer is no. There's no good reason as to where we draw the double bond. It was thought originally that the double bond, which you can see here is shown in 3 different places, would jump from one bond to the next. It would on the right, then the left, then down, then the right, the left and down, and so on. And that's why the term resonance came to be coined. We don't quite buy that jumping around idea anymore. Instead, this double bond, we believe, is smeared out. It's spread out equally over all these 3 bonds, which is to say that these nitrogen-oxygen bonds are not single bonds, they're not double bonds, they're something in between. Each one is something in between. You can see that the Lewis structure model here is not adequately representing reality. Resonance structures are not a hop, skipping, and jumping of bonds, but are rather a blending of Lewis structures. When you draw resonance structures, first of all, you need to show them all, and secondly, the atoms remain in place. It's not the atoms that move around, it's the electrons that you show being in one place or the other. When drawing resonance structures, or trying to decide if you need to draw an additional Lewis structure for a given species, you want to ask yourself this question: is it fair that this bond should be a single bond and that bond should be a double bond? And if the answer is no, then we have resonance, and you're going to need to draw however many Lewis structures it takes to represent that adequately. Going back to this Lewis structure in the upper left that I drew here, is there any good reason why this oxygen-nitrogen bond should be a single bond and this one here should be a double bond? And the answer is no. We have resonance, and we need to draw all the Lewis structures. Aromatic compounds are based on resonance structures of the benzene molecule. Benzene has 6 carbons and 6 hydrogens. The carbons are in a planar ring with 1 hydrogen attached to each carbon. The total number of valence electrons is 30 in benzene. Now, let's ask ourselves, is there any good reason why this carbon-carbon bond should be a single bond, and the one to the right of it, why that carbon-carbon bond should be a double bond? Is there any good reason for that? And the answer is no. And so what we have is resonance. And again, what resonance means is, in the case of benzene, that these carbon-carbon bonds are all equal to each other in terms of their bond length, in terms of their bond enthalpy. They are not single bonds, they're not double bonds, they're something in between with regard to both length and strength. And just as an aside, in the interest of efficiency, benzene is often represented like this because it's much quicker to draw